All right, so in this video, what I want to do is explain where this 68, 95, 99.7 rule comes from for normal distributions. Which we know can be represented with n and then mu representing the mean and sigma representing the standard deviation. And first I'm going to claim that actually you have the tools to derive this rule yourselves. And so what I'd like you to do is either here or at some point in the video, once you have a kind of head start, pause the video and see if you can actually see how to calculate this, maybe this 68% yourself using the standard scores and the percentiles for normal distribution. So those two tools will allow you to calculate the values associated with this rule. But okay, so let's do the 68% together. And so 68% is the answer to the following question. So what percent of data points for a normal distribution are within one standard deviation of the mean. And so if this is the mean, then it's asking what percent of data points are either one or less than standard deviations to the right and one or less than standard deviations to the left. So it's asking what percentage is this blue region in this picture. And so again, because this is a normal distribution, it's representing all of our data. We know that 100% of our data is underneath this curve somewhere. And this is asking us to just kind of calculate a specific area of one smaller part. Okay, and so to do that, I'm going to claim that the standard scores and the percentiles are all that we need. And so recall, given a standard score or a z-score, let's say z, then the zth percentile looks like this. So if this is my normal distribution, here's my mean, and let's say this is z, somewhere out here, then I'm going to say that if z has some percentile, so z has maybe p percentile, then if I shade everything to the left of z, then this green part is equal to p% of data. So saying something or something with standard score z has pth percentile, this means that p% of my data is less than or equal to z. And in particular, we know that the mean, mu, has percentile 50. It's 50th percentile because it's exactly in the middle. Half of my data is to the left and half of my data is to the right. Okay, so what we're after is finding out the percentile or the percent of data between this standard deviation up here and this one. And so what I'm going to do, and let me encourage you if you haven't already to pause and find out what things I need to calculate and why. Okay, so what I'm going to do, again, let me draw another picture of a normal distribution. So maybe a better picture. All right, so again, here's my mean, and here's my first standard deviation. So 1 standard deviation away from the mean, whatever that is. And I'm going to calculate that one's percentile. And so if I do that, what I'll be getting is the percentage of data that's in this area. So if I have standard score 1, then I look at table B, or that website tells me that this is, and I look at the table and I see that its percentile is 84.13 percentile. So that tells me then that 84.13% of my data is in this blue range, which would mean then that approximately 16% is over here to the right. Okay, but what I'm really interested in is this blue range here. So notice that this 84% accounts for everything to the left of 1, which means that this portion here is being counted, but I don't want to count it. But notice this portion here is exactly equivalent to the percentage of data that's less than or equal to this -1. And so I go over here and I can find out what that is. So here's the -1, and then this part over here, I don't want to count. So I don't want this. But I can figure out what that is. So again, here's mu, here's my -1, and I can find this percentile. So go here, and this is what I'm calculating. I want to know what area that is. So I have standard score -1, and table B tells me that this is 15.87 percentile. And so here, let me draw that on my original picture. So that's over here. So all of the blue is 84.13%. And this right here is 15.87%. And if what I want is this yellow area, the sparkle yellow, then I see that I need to take this blue amount and subtract from it the pink amount. And so what that means is that I take my 84.13 and I subtract from it the 15.87. And if I do that, of course there's lots of canceling, I end up with 6 and 2, and that should have been 3, 8, and 6. And then if I round this, I get 68%. And that tells me then that between 1 standard deviation to the left and 1 to the right, this area right here is equal to 68%. And what I'm going to claim is that if you wanted to do the same thing for between 2 standard deviations, or within 2 standard deviations of the mean, so you wanted to replace this question with a 2, you would do the same process, only looking at standard scores for 2 and -2. And similarly, if you wanted between 3 standard deviations, you would look at standard scores between 3 and -3.